Okay, law of sines. Before we get to the actual law of sines, let's do some area problems. So the area formula for a triangle is 1/2 base times height, or base times height divided by 2 if you prefer that. Okay, and your base and height have to be perpendicular to each other. So if I use 4 as the base, then I'd have to use 3 as the height. So that's a good base height pair because they're already perpendicular. So 1/2 of 4 times 3. So half of 12 is going to be 6. So this is 6. I don't know what the units are, but I know the units are squared because it's area. So 6 square units. Okay, pretty straightforward. All right, so let's try this next one. Here's my formula. Oh, we've got a little problem because these aren't perpendicular, right? I know they're not perpendicular. I don't know what these angles are, but it sure doesn't look like it's perpendicular, and I don't have this side anyway, so I can't use 6 and 5 as a base height pair. All right. So what I'm going to have to do is make myself some right triangles, okay? So I'm going to make an incision like so, perform a little surgery on my triangles, okay? Now don't assume that that's 3 and 3. We don't know if that's the case. We don't know if this is going to bisect this side, okay? But we actually, what we can do is we can find the height of this triangle, so which is right here, okay? If I'm using 6 as the base, then this would be the height, all right? And I can find the height of that if I'm just thinking about this triangle. I actually have enough information, okay? We're not going to use the 6. Don't assume this is 3 again, okay? So I'm just going to ignore the 6 for a second, but even with just this information, I can find the height because I can use SOHCAHTOA, okay? So I want to imagine myself here over at this side. Then I'm dealing, this would be the opposite, and this would be the hypotenuse, so I'd want to use sine, okay? So now I can say the sine of 70 degrees is going to equal h over 5, the opposite over the hypotenuse, okay? If I want to solve that for h, I'm going to multiply both sides by 5. Those will cancel. And now I've got something that I can plug into my calculator if I wanted the height of that, okay? Which is totally fine. You can plug that in like that. But I'm just going to leave my height as this total. So I didn't arrange that very well there. As this, that's my whole height. So my base was 6, and my height is going to be 5 times the sine of 70 degrees, which I could put in my calculator. It's just a decimal, right? Okay, so let's clean this up a little bit. Half of 6 is 3. So I've got 3 times the sine of 70 degrees. So this 3 times 5 is 15. So if I simplify that, there we go. Okay, and now I'm going to put it in the calculator. I could have put it in the calculator at the beginning. I was just waiting till the end to clean it up there. Okay, so let's see what we get here. You want to be in degree mode. I'm in degree mode here. Good to go. So 15 times the sine of 70 degrees is about, does this ask me? It doesn't say how to round. I'll call that about 14.1. Usually I like to go the nearest hundredth, but that rounds nicely to 14.1. And I don't know the units either, so I'll just say that many square units. Okay. So even when we don't have a base height pair that is perpendicular, you can sometimes get around it by drawing in your own height and using SOHCAHTOA to find it. Okay. All right, so that brings us to the SAS triangle area formula. So if you look at this last example, I've got 2 sides and an included angle. And this is the situation where we are going to be able to find the area by with this method that I just showed you, okay? So this formula is really just a souped up version of 1/2 base times height, okay? And the way we're going to find, the way we're going to do this, the height, if we look back at the last problem, the height ended up being 5 times the sine of 70. 5 was one of my sides, and sine of 70 right there. Okay, the other side, the base was the 6, right? And then the other side went in the height with this angle. So the part that's getting souped up here is the height, okay? So the area, I should really say A, instead of A, because this could be side A, I should say the area equals 1/2 of the base. And then I have a lowercase c here, which is going to represent one of the sides. And the sine of A. So here, let me put in the word area here so that doesn't get confused with A. Okay? And this is my, my new formula for the SAS situation. Okay? So let me show you how it works on this next problem. So you could cut this up like you did in the last problem, but you actually wouldn't want to cut it down this way. You'd want to cut it like that if you're going to cut it. And then go for finding the height from there. But for a shortcut, I'm just looking at this and thinking, okay, I've got two sides and an included angle, all right? These are going to be the sides, and this is going to be the included angle. So if I can remember this formula, my area equals 1/2 of BC times the sine of A. Well, here's my sides, here's my angle. So my sides are going to be 6 and 7. And then the included angle is 80 degrees. Okay, so even though this is a little bit complicated to show you how this works, once you know the formula, if you know where to plug the pieces in, these problems are very simple. So let's see, 1/2 of 6 is 3, right? So this is going to be 21 times the sine of 80 degrees. And let's put that in the calculator. Got to get that right at the right angle so you can see it. Why do they make this so hard? Okay. So 21 sine of 80 degrees. And that's going to give me about 20.68. Okay, and again, if you don't know the units, you still should say that they're square units when we're dealing with area. Okay, the section is called the law of sines. This is not the law of sines, even though it does use sine in it. This is the SAS triangle area formula. Okay, so let's get to the law of sines on the next page. So I've got this triangle. Notice that side A is across from angle A and so forth. The B's are across from each other. The C's are across from each other. Okay. All right. So let me, like I did on that first example, I'm going to draw in a height here. Okay. And that means I've got two different right triangles then. Okay. So what I'm going to do is I'm going to use the triangle on the left half and set up a sine. The sine of A, and it's going to use H. So sine of A, well, that's going to be opposite over hypotenuse. My opposite is going to be the H. The hypotenuse is going to be the B, the lowercase b. Okay, so I'm being really careful with uppercase and lowercase because I'm sometimes not careful about that. Okay, so I use this triangle to get that. Let's do the same kind of thing from B. So if I'm finding the sine of B, that's the triangle on the right, I can use that because it's a right triangle. Opposite is H, and hypotenuse is A, okay? Now, both of these, I'm going to solve these for H. If I wanted to solve this for H, I'd multiply both sides by B, and I get B times the sine of A, okay? That's going to equal H, right? Over here, I'd multiply both sides by A, and I'd get this, okay? So now, the thing, this H, it's the same H. It's the same line in the bigger triangle, okay? So that means that, hey, I can use transitive property or substitution here to say that this is going to be equal to this. Okay? And so, hey, I've got B times this. I've got A times this. All right? So if we think to our last chapter when we were doing a lot of proportions, when we had two fractions that were equal to each other, we did cross multiplying, okay? So I can build a proportion in reverse. because this times this, well, they would be diagonal from each other in a proportion then, right? So I'll put the sine A up here, and then that means the B would go down here. I can do the same thing on the other side. These two should be diagonal from each other. I'll put the sine of B up here, and then the lowercase a down here, okay? And so this is the law of sines. And we could have done the same thing. I could have cut this up from corner B and done the same kind of thing using a height. You're not going to have to solve for this law of sines, but I'm just trying to show you why this works. So the sine of A over A, so I call those my A's, right? This is the sine of angle A over side A. That's going to be equal to the sine of angle B over side B, and I didn't show this with the C's. I'd have to cut it from one of the other corners, but this is also going to be equal to the C's, the sine of angle C over side C. You could also take this whole proportion and flip it upside down, so you can have all your sine of the angles on top or have them all on bottom. It doesn't matter, but you got to be consistent with it, whichever way you're setting it up. Okay, this is the law of sines. It's a pretty easy one to remember because the A's are on top of each other, the B's are, and the C's are all in one fraction too. Okay, and on this next problem, I forgot to write in the numbers here. There were supposed to be some given numbers. I'll fix that on the note-taking guide. So let's see. Let's say we knew that this was 66 degrees, and we know this is 80 degrees. I swear I wrote those in, but they disappeared somehow. Okay, so let's say we have this problem, okay? Now, what we can do with the law of sines, if I'm trying to find the side B, first thing I would think of, well, do I have a right triangle? Because if I do, then I can use Pythagorean theorem maybe, or I could use SOHCAHTOA, but here I don't have a right triangle, okay? So you could try to cut it up into right triangles, and that will actually work if you do it in the right way. But it's going to be easier to just use the law of sines because cutting this up into triangles ultimately is going to get us this information, okay? So here I'm solving for B. So what I want to do, I want to use the cross pairs. I want to use, I'm definitely going to use my B's, okay? So when I say cross pairs, the B's are across from each other, side B and angle B. And since I'm trying to solve for side B, I definitely want to use that cross pair. Okay. Now I'm going to use one of the other pairs. I'm going to either use the A's or the C's. If I use the A's, I don't know either of the A's, so that's not really going to do me any good. So I'm just going to leave them out of that. I'm going to use the C's because I have both of these. Okay. So I'm not going to use the whole proportion here. I'm only going to use the B's and the C's here. Okay. So I'm going to forget about the A's because I don't need them here. So I'm going to use this proportion. So I'm going to say the sine of angle B over B is going to equal the sine of angle C over C. Now, let's plug in what we know because we have most of this, okay? Angle B is 66 degrees. Okay, side B I don't know. That's what I'm going for. This is angle C, so I'd have sine of 80 degrees up here. And then side C would be 43, okay? So now, looking at this, I've only got one variable in here, so I can cross multiply. Remember, I can plug the tops of these fractions into calculators. They're just going to be decimals, right? And I will do that at the end of the problem, but I'm just going to simplify this first. I'm going to try to solve this for B first, okay? So I've got B times the sine of 80 degrees. I would put the B in front of the sine of 80 degrees. Because I want to show that it's not inside of the sine, okay? And then on the other one, same way over here, I'm going to do 43 times the sine of 66 degrees. It's like a coefficient, right? It's 43 times whatever this decimal is, B times whatever that decimal is, okay? So I'm trying to solve this for B. I want to get B by itself. Well, it's B times the sine of 80 degrees. So I can just do this to both sides of the equation, because then these will cancel, okay? So now I've got B equals the 43 of sine of 66 degrees over the sine of 80 degrees. Okay, and then I need a calculator to finish that off. Okay, so let me get out my calculator. Try to tip it the right way so you can see the screen. All right, so you can type in, if you have a fancy calculator, you can type in the whole thing like this. I would put the top in parentheses and the bottom in parentheses too if you're going to do it that way. A safer way to do this is to find, to do the top and the bottom separately. Okay, so there I've got 43 times sine of 66. On bottom I've got sine of 80 degrees. Okay, and now I'm going to do division. I'm going to do the 39 number over the 0.98 number. Now, don't round these too much. The more you use of the decimals, the better of an answer you get. Okay, if I just round this to 39, my answer's not going to be great. So the more of these numbers you use, the better. I'm probably overdoing it. I'd say if you go 4 or 5 decimals, you'll be fine. But don't just round it to the nearest tenth or something like that. Definitely not to the nearest integer. And then I've got about 39.89 if I round that to the nearest hundredths. Of course, you're going to have to round your final answer, but try to avoid rounding as you go if you can. 39.89. And there is side B. Okay. Oh, I see what I did. On the next page, I had that same example. Okay, so that was this example we just did. Okay, so I'm not going to do this one again. It's what we just did. Oh, I see. We solved. I did want to split this up. We solved for B. Okay, so let's say we're trying to solve the whole triangle. You have to know what this means. This means find all missing sides and angles. I got myself confused here. I thought I had the same problem twice, but if you look at the directions, I just asked you to solve for B on the last problem, okay? So I'm going to use my answer from above. We just found out that this is about 39.89, okay? If I was doing this problem from scratch, I'd start by using the law of sines to get side B. There's other things you could do. So I'm still missing both of the A's, okay? So what I'm going to do now, I'm going to find this angle. Even though you need one of the A's to do the law of sines. But wait a second, I don't have to do the law of sines because I have 2 of the 3 angles in this triangle. Okay, so that means I can say, all 3 add up to 180 degrees. So don't forget about the triangle angle sum theorem. So let's see, I've got 146, measure of angle A plus 146 equal 180, and then I'll subtract 146, and that's going to come out to 34 degrees, right? Okay, so this is part of my answer. This is part of my answer. I always like to put my angles and sides back into the picture for 2 reasons. One, it reminds me when I'm finished, when I've got all the pieces, but also I can often use the pieces to find other pieces. So it's helpful to have it visualized in the picture. Okay. So now I'm still looking for side A, and what I can do is I can do the law of sines again because now I have one of the A's. Okay. Now I've got both the B's. I could use those, but I'd rather not use that decimal. I'll use these 2 because I've got nice round numbers. So I'm going to use part of the law of sines now. The bell rang and I got interrupted there. But I was about to use the law of sines to find angle A. So I'm going to use part of the law of sines. So I'm going to say the sine of A over side A is going to equal, and I'm going to use the C's. Sine of angle C over side C. Let's just plug in the pieces we know here. Okay, so I know angle A is 34 degrees. Side A I don't know yet. Angle C is 80 degrees, so this is sine of 80 degrees, and this is 43 for side C. And now I can cross multiply to find angle A again. Okay, so let's go ahead and do that. 43 times the sine of 34 degrees is going to equal a times the sine of 80 degrees. Okay, and I want to solve for a, so I'll divide by the sine of 80 degrees here. Okay. So a is going to equal this mess, but my calculator can sort that out, right? So let's see. 43 times sine of 34 degrees is this, and then the sine of 80 degrees is this. And you know, these calculators are nice because you can see your previous answers, so you might need to jot these decimals down as you go. So let's see. Divided by 9848. Okay, put in more of the decimals than I probably needed to there, but then rounding to the nearest hundredth, I'm going to call that 24.42. So this is about 24.42. Okay. And now in the picture, that's the last piece, right? Now I've got it all. I've solved this triangle. There's no more mystery. I've got all of the pieces. Okay. All right, let's try one more. I'm not going to ask you to solve the whole triangle on this last one. It's just going for one of the angles. Okay, so over here, I'm going for angle A, so I definitely want to use the A's. And then I want to use either the B's or the C's. Well, B's, I don't have either of them, so let's use the C's. I'm going to set the A's and the C's equal to each other again. So sine of A over side A is going to equal the sine of angle C over side C. Let's plug in the pieces. Angle A I don't know yet, but I do know side A is 8. Angle C is 50 degrees. And then side C is 7 degrees. Okay, there's my setup. So let's start cross multiplying to begin with. All right, sorry about the bell there. 7 times the sine of A is going to equal 8 times the sine of 50 degrees. Okay. All right, so I'm trying to solve this for A. So I can start by dividing both sides by 7, because then those 7's cancel. Okay. Now, ultimately, I'm solving for A, and the only way to get it out of this sine function is to use inverse sine. And you could do that right now, but then I'm going to have 2 signs in there. I'm going to have the inverse sine of this whole fraction, and sometimes that freaks people out. But what I'm going to do instead is just convert this into a decimal, okay? Just to make it look a little nicer, and it's a little less intimidating. So I'll take my calculator, make a decimal out of that fraction on the right side. Otherwise, there's going to be like a sine function inside of an inverse sine function, and it looks a little intimidating. But remember, 8 sine of 50 divided by 7 is just a number, right? It's 0.875, something like that. Okay, so let's see, 0.875. This is 0.875479336. That's as much as my calculator will give me. Okay, now I'll do inverse sine. So to isolate, the inverse sine is going to switch the position of those 2 things, right? So the inverse sine of that long decimal, okay, I'm not going to rewrite the whole thing there, equals that, okay? So then I'm going back to my calculator again. I'm going to do the inverse sine of that long decimal. The more of it you use, the better. And then that's going to be about 61.10, okay? So then A, and this is the measure of angle A, really, right, that we're finding, is about 61.01 degrees. Okay, we're in degree mode, so that gave us, don't forget to put the degree symbol. Otherwise, it's 61 radians, which is something totally different. Okay, And there we go. So sometimes when it's an unknown angle, you'll end up having to use inverse sine. Okay. But you can still use log sines really in the same way. That's it for today.